All right, so today we're going to finish off our chapter, lesson 9 of 9, qualitative graphs. So we're moving on from quadratic, which are curves, to definitely some different looking graphs. So if we put our name and date on here. Okay, so we have our vocab word on slide 1. It says analyzing qualitative graphs. The graph shown is a qualitative graph. Qualitative graphs are graphs used to represent situations that may not have numerical values, or graphs in which numerical values are not included. So if you look down here, we have a graph, and it looks kind of funny. It says axes are labeled but do not include numerical values because maybe they stretch to span too long of a time. You can see the relationship between the time and percent of photos downloaded. So it says percent downloaded and time. So it looks like if we were looking at this, it grew at a steady rate, increasing, then it leveled off for a while, then it was even faster download, leveled off for a while, and a quick download once again. So we're going to see those coming up here in a second. So on slide 2, it says, Emily is downloading photos from her digital camera to her computer. The table shows the percent of photos downloaded for several seconds. During which period of time did the percent download not change? So all of our seconds change, but on the percent downloaded, if you see here, from 4 to 6 seconds, nothing changed. And from 8 to 10 seconds, it stayed the same. So that's what they're looking for here. During which periods of time, between 4 and 6 seconds, and 8 and 10 seconds. So it's going to look specific on the graph with no growth. During which period of time did the percent download change the most? So here we go from 0 to 15. So this is a 15, a 15, a 0, a 34, a 0, a 18, and an 18. So it looks like from here to here, 6 to 8 seconds, it changed by 34%. So if we were to graph these, we would have time on the x-axis in seconds and percent downloaded on the y. And if we graph, we'd have 0, 0, and then 2, 15, estimating, 4, 30, 6, 30, 8, 64, 10, 64, 12, 82, and 1400. So if we connected these dots, here is a growth, here's a growth, there's no growth at 0 seconds. Here's a steep growth, fast growth, and then growing, but at a little slower pace because this is a little steeper of a line. So we connected the ordered pairs. So we're representing this segment, or this table, with these different line segments. So here, they're going to ask us to describe a graph. The graph at the right displays the water level in a bathtub. Describe the change in water level over time. So basically, they're showing us here, but we're going to write a story about this. So we would say the graph level in the bathtub. So the water in the tub, this is a constant rate, flows in quickly at a constant rate. Why would there be no change? Well, because someone's in the bathtub. The water level stays the same during the bath. The plug is pulled. And water leaves at a constant rate. So tell me a story. The more clever, the better. The funnier it is, the better it is. Just as long as it makes sense with our graph. Okay, so slide 4. Letter A. The graph on the right displays the temperature throughout the day. Describe the change in temperature over time. So it looks like it starts off kind of chilly. It gets warmer, warmer, warmer. Then it starts to cool down. So we can just write that. If you have more details you want to put in, go for it. So the temperature increases throughout the day. Throughout the day. Now this isn't at a constant rate because it's not a straight line. And then it said we increase throughout the day, hits our hottest point, or hottest temp, and starts to decrease. If you want to add more details, you sure can. The graph represents the revenue, so that's money, from a local clothing store. Describe the sales over time. So it looks like they had a steady increase in sales. Started with a steady increase in sales, lost some money, increased again, slowed down right here, almost to just staying the same, and picked up again. So I basically described every little curve on that line. When in doubt, explain as much as you can. Now we've gone from seeing them, now we're going to go to drawing them ourselves. Qualitative graphs represent the essential elements of a situation in a graphical form. You can sketch qualitative graphs to represent many real-world functions that we describe verbally. Think of what it would look like in your head. Then think about what the graph would look like. They should be similar. Slide 6. A tennis ball is dropped onto the floor. On each successive bounce, it rebounds to a height less than its previous bounce until it comes to rest on the floor. Sketch a qualitative graph. So, what are we talking about? We're talking about usually time. Over time, the height of the ball decreases. So it starts at 0, or maybe you drop it in your hand. You're holding it here, you drop it. It hits the floor, then it comes back up, but less, it says. And then it hits the floor and comes back up, 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 and then it slowly rolls away. Slide 7. A car is traveling at a constant speed. The car slows down steadily, that would tell you a straight line, to come to a rest at a stoplight. Sketch the qualitative graph to represent this. So we're talking about speed and usually time. So we'll say speed, or time on the x-axis, speed on the y-axis, because the speed depends on time. So traveling at a constant rate. So I'm just going to say they're up here traveling at a constant speed. Nothing's changing, nothing's changing. The car slows down steadily, it says. So it slows down steadily, comes to rest. So if it's coming to rest at a stoplight, so then we can think that its speed is 0 at a stoplight. Oh, well, there we go. Then it's done. Doesn't say that it speeds up again. I was thinking maybe it would speed up again. But here's our constant speed. We're traveling at a speed. We slow down to a stop at a red light. There we go. Just one variation. There could be other things too. Last but not least, sometimes we think, what is a friend? And then we say, friend is someone who shares to share the last cookie with. Have a great day.